Hello everyone, I'm Keheliya, a PhD student from McGill University. Today, I'm going to talk about our work titled Accelerating Continuous Integration by Caching Environments and Inferring Dependencies. This work was recently accepted to be published in the Transactions of Software Engineering journal. And also this work was a collaboration with Yves Inc., a software company building tools to improve developer productivity. In modern software organizations, developers push their changes into version control systems frequently. This initiates the CI process, building the changes, testing them, and reporting the results back to the developers. Continuously doing this process repeatedly is called continuous integration. Some organizations go a step further and do the deployment to production also continuously. We call it continuous deployment. And some go even further and collects telemetry data during production runs to do continuous experimentation. However, if some stages of this process such as build and testing become slow, it becomes problematic. It affects developer productivity, costing time and resources for the organizations. Usually, the solution to such a scenario is building a new tool. However, these new build tools require manually specifying build dependency graphs. If the build dependency graphs are overspecified, it puts constraints to parallelization, affecting the performance unnecessarily. And if the dependency graphs are underspecified, the builds become non-deterministic, causing problems. Therefore, manually specifying build dependency graphs is not an ideal solution. Also, replacing existing build tools requires a lot of engineering effort. Therefore, we propose Kotinos to accelerate CI without having to replace existing build tools. Kotinos accelerates CI in two ways. First, caching of the build environment, and then skipping of unaffected build steps. Kotinos does all this while being language and build tool agnostic. Now let's see how the first approach of caching of the build environment works. When an initial build request is received by Kotinos, it gets an OS image as specified in the CI configuration and install all the language tools chains and the dependencies required to continue the CI process on this Docker image. And then the subsequent steps of the CI process such as compilation and testing is done on this image. Once the CI process is completed, it reports back the results, the build outcome to the developers, and the image used for the process is saved in the environment cache. When the second build request is received, it reuses this image from the environment cache without having to set up the environment all over again, and thus saving time. Now let's look at the next technique, skipping of unaffected build steps. Kotinos collects system calls during the initial build process, and it identifies files read and written during each build step using these collected system calls and builds a dependency graph. This graph is used in subsequent builds to skip steps. So in this example, file 1 is changed during the commit. Because step 1 of the build process is affected by this change, we cannot skip step 1. We have to execute it. This step writes to file 2, causing step 2 to transitively affected as well. This means Kotinos have to execute step 2 as well. However, during this commit, file 3 is not modified. Therefore, step 3 is not affected. That means step 3 in the build process can be skipped and only step 1 and 2 will be executed, saving some time. Next step was evaluating these two approaches that we implemented. We used 10 subject systems for our evaluation, 3 proprietary and 7 open source systems developed using multiple programming languages and having code up to 1.4 million lines of code. Our evaluation is based on 3 criteria: how often are accelerations activated in practice, how much time do the proposed accelerations save, and what are the costs of the proposed accelerations. In terms of the cost, we look at what is the resource usage of our approach and whether the correctness is affected by our approach. First, to find out how often these accelerations are activated in practice, we looked at the logs of builds run on Kotinos during the period of 4 months. We found out caching is the most common technique, and 87% or more of the builds are accelerated by at least one technique, showing Kotinos is beneficial in practice most of the time. Then we compared build durations of accelerated and non-accelerated builds in 3 proprietary projects. In pink, we show the builds that were not accelerated, and in green, we show the accelerated builds. Here, we demonstrate that Kotinos achieves at least 2-fold speed up in 74% of the cases. And then we replicated this in open source projects by rerunning builds with different accelerations enabled. The difference between this and the previous approach we followed was we ran each commit 3 times without any acceleration enabled, only with caching enabled, and both caching and step skipping enabled. In these graphs, we show results of 3 projects. Blue line shows the build duration when no acceleration is enabled. Yellow is with only caching enabled. Orange line is with both caching and step skipping enabled. Here we can clearly see build duration is very low when the acceleration is fully enabled. To look at the resource usage, we collected resource usage while the builds are run in terms of 3 aspects: RAM, CPU, and the storage size. Here we can see the median usage of all these 3 resources are very low, and there were some outliers. You can read more about these outliers in our paper. To check the correctness of build output run by Kotinos, we compared the build status of 466 commits built both on Kotinos and Circle CI. We found out 100% of Kotinos build outcomes are consistent with Circle CI build outcomes, showing the Kotinos is doing the correct thing, providing the correct output even with all the acceleration steps. We are proud to say Kotinos is at the core of a commercial CI service called Yves, with a growing customer base ranging from startups to Fortune 500 companies. To summarize, suboptimal CI wastes time and resources. Kotinos accelerates CI in 2 ways. We evaluate Kotinos on 10 subject systems, and we show Kotinos can accelerate CI builds with minimal overhead. For more details and to read the full paper, follow this link. Thank you very much.